Welcome to another Sawtooth webinar. We're grateful to have you today. Hope you're having a good morning, afternoon, evening, wherever you are in the world. It's good to be with you. The title of this webinar is The Will of the Many: How AI and Crowdsourced Input Drive Breakthrough Design. And we're grateful today to have Peter Lee and Joris van Gol from SKIM joining us. Uh, they're two great fellows. You're going to enjoy them, and happy to have them today. Few details before we get started. We will use the Q&A section at the bottom of Zoom here to ask questions. Please don't use the chat. At the end of the webinar, we'll have Q&A, so make sure to ask your questions there in the Q&A section. Maybe they'll answer your questions during the webinar. If not, they'll answer them at the end during the Q&A. For everyone who registered, we'll send out a recording of the webinar, and Peter and Joris have also agreed to send out their slides, so you'll get both their slides and the recording. Okay, some upcoming Sawtooth events I want to make sure you're aware of. We're excited for another webinar next month, July 17th, entitled Relevant Items Max Diff. Its origin, motivation, and option from Chris Chapman. So for sure you're going to want to catch that one coming up July 17th. Closely thereafter, July 21st through 22nd, we will have our Sawtooth research training out here in Lehi, Utah. We'll be covering subjects, customer feedback, content analysis, market simulators. We really encourage you to come out. Utah is very beautiful this time of year. Come out and get some good training and see the beautiful mountains here in Utah. And finally, in September 25th through 26th, we'll have our preference modeling event out in Nuremberg, Germany. So you can go to sawtooth.com/events for more information on all of our events. If you're new to Sawtooth, we really encourage you to check us out. We have a powerful survey platform. We're really good at conjoint analysis and max diff, but we're also good at all types of surveys you can do on our platforms. We're easy to use. We have incredible support, and you can try us for free at discover.sawtooth.com. Not sure what I'm going to do with this slide here, but I thought it was an interesting comic that Peter and Joris have developed. Maybe after I introduce them, they can kind of tell us how they kind of met and how they got started on this idea at SKIM. Peter and Joris did receive the best paper at the Sawtooth Research Conference this year in New Orleans. So that's one good reason to have this webinar, is to show you what all the hype was about and have them present their excellent presentation. And my understanding is they've added a bit more to their presentation than they gave at the conference. So you'll get an even better view of what they were talking about. So I'd like to introduce Peter Lee. He's an expert at machine learning engineer. He's bringing advanced AI techniques to SKIM. And I think that's him there on the left in the spacesuit. Joris van Gol from SKIM also is an advanced quantitative researcher. He's an expert at choice-based methodologies, and he's great at delivering robust data-driven insights for leading brands. We also have Drew McGinnis from Sawtooth here to help answer any questions. We appreciate him. Well, Peter and Joris, would you like to turn on your cameras?
Yeah. Thank you, Justin.
Would you maybe talk us through this comic strip?
Yeah, so in August 2024, we were talking about, well, Peter joined the company not that long before that.
Yeah, beginning of last year.
So then we were talking about, what we're doing with AI, because a lot of companies were doing stuff with AI. And I have to admit that back then I was a lot more skeptical than I am now. So the comic is sort of playing on that, where we were like, I was like, we're doing it like all the other companies, and then saying that it wasn't fast enough and not good enough yet. And we came to the conclusion, well, actually, we can do something really cool with it. And well, I had already been to Sawtooth once. Peter had gotten a taste for conferences as well. So, and then I told him, well, if we do this, probably we can get to Sawtooth and we can present there. We can go to another cool conference. So that's sort of how we got here.
Cool. Love the comic strip. I noticed that in the second pane you've removed your glasses. I don't know if you caught that.
Yeah, yeah, this was actually quite rough to generate. Like getting the strips to show us in the sort of the same art style was too difficult, pane by pane. So we generated them all four at the same time, and this was sort of the best because we generated a few where our faces would swap, or suddenly we'd be wearing each other's outfits and stuff like that. So yeah,
And I just love this image here. It's so great. So anyway, I guess we'll get into why the image, but why don't you share your screen and take it away?
yes. Let me find the button. It should be working now.
Yes, I can see it. Looks good.
Great. All right, then I'll do a little bit of an introduction. So, thank you all for your interest in our presentation. The Will of the Many, or the unofficial title, Peter and Joris Search for the Meaning of Christmas. You'll see why that makes sense as the unofficial title as we go through the presentation. I'll be doing a lot of the more research and conjoint parts, and Peter will be taking care of all of the AI and image generation parts that are more technical. As Justin mentioned, we have added a little bit to our presentation after the Sawtooth conference. The quality of the models is improving incredibly fast, and we can do more and more, well, almost every month. So we've also we had a few things on the wish list at the end of the conference. We said, well, in the future we're going to look into these things, and actually a few of these things have already happened. So we've already been able to experiment with them, and we've added a little bit of where we're going with that at the end of the presentation. So then, diving in. I'll start with a little introduction of the problem that we're trying to solve. Then Peter will talk a little bit about image generation and the modeling. I'll take us through the results and what we can do with this from a market research perspective. And then finally, we'll have a discussion and future plans. So, as an example problem, we have an international soda brand, and they want to launch a limited edition can for the USA. So for this, they need to understand local design preferences to maximize sales, and they hire local designers as they always do. And they, of course, already have sort of a plan of what they want on the cans. Everything goes well. They evaluate them in a survey. They come to these can designs, and they run them, and it works well. They get quite some good responses. Everything goes well. The cans sell reasonably well. But then again, when they were evaluating the designs, there was people that said, well, we're still missing, say, more of a family or more of a sharing thing that we normally have with this holiday occasion, and that's not visible on the cans at all. So then the wonder is from the company, if we had that, could we have had more? Did we not explore the entire design space? And that sort of gets us to our problem, namely that finding the best design is a very challenging problem. There's an infinite design space. There's millions of ways that you can make a Coca-Cola can for, well, any holiday, in our case, specifically Christmas. And there's only very few designs that are actually like the perfect design that will really resonate well. And then the question, of course, becomes which key features are the features that are going to resonate well with consumers? What do you need to have on your can for consumers to really have that feeling of, in this example, Christmas? So we had a few approaches here from past research during the conference, and essentially I'll summarize them really quickly because we went into some depth that's not necessary, but none of them really explored the design space. They only really looked at exploiting the image models that we have in order to enhance, but not allow the consumer to explore the design space themselves. And that's where we want to go with our plan. So for our research design, we had four core modules. First, we screened people to see that they bought Coca-Cola cans. We did some behavioral questions, but the most important part, we did image generation. So people got 3 tries to generate a Coca-Cola can that they really liked with a Christmas theme. After that, we also did a ranking exercise to check how do their cans do and how do their cans do against others as well. So it wasn't that we did a two-part survey. We actually had one survey where people would generate images. Those images would then go into a database, and then they would rank images from that database from other people that also generated their own designs. So it was creating and evaluating all on the fly. So why did we go for image generation? Text-to-image models allow us to instantly translate ideas into visual designs. And this is really the power of it, is that you immediately get to see what did I actually ask for. If I ask for a Christmas can with a polar bear, is that can that comes back, is that actually going to look pretty? Is that going to make me think of Christmas? Is that going to make me all warm inside? You immediately get that feedback. If you wanted that normally, you would need a designer, and that is, of course, expensive and very time-consuming. So here, a quick example of the evaluation. So the evaluation consists of two parts. First, we did a max-diff exercise, and after the max-diff exercise, we also did a anchoring exercise where respondents could compare the Christmas can that they generated to a regular Coca-Cola can, which one they would buy, which one they would definitely buy, and which one they wouldn't really buy over a regular Coca-Cola can to get that anchoring in. I noticed that in us trimming the slides from the conference, somehow a important slide from legal disappeared. During this entire presentation, we'll be doing Coca-Cola cans. However, we do not have Coca-Cola sponsoring us. We do not have the endorsement of Coca-Cola. And the only real reason we're using Coca-Cola cans is that it's something with a very high IR. So our survey was very cheap to field because almost everyone said yes to, do you ever drink Coca-Cola? And that image models at the time that we did this research weren't that great yet. So generating a brand that wasn't very big was difficult. So essentially, we needed a brand that would be picked up by the image model and the logo would be there and it would work.
Yeah, thanks. I'll be now going over the image generation. So the out-of-the-box text-to-image models that most of you are probably familiar with, that you've heard in the news, like DALL-E, Midjourney, they are general-purpose models, which means that they've been trained on large sets of data from the internet. However, they are not very good at generating images that were not included in the pre-training. And since pretty much all the top models are actually closed source or only open weights, which means also data is not available, it's impossible for us to tell a priori whether any given model is able to generate the image that we want, which in this case Coca-Cola cans. So our first task was to find out which models are actually capable of doing what we want to do, and which among those is again the best. So the first we defined three methodologies of different approaches for this. The first one is to just use the aforementioned general purpose models. These are available through either API providers such as Imagen or from Google or DALL-E from OpenAI. Additionally, there's also a large amount of open weights models available through Hugging Face. The second approach that we tried is called control nets. We'll go into depth right after this in the next slide. But essentially what they are is that there are models that can be combined with the default models, and they allow us to specify conditions that the generated image has to satisfy. And then finally, we try fine-tuning. What this does is that, so as explained, the general purpose models, they are trained on these large amounts of data just collected from the internet. And then for fine-tuning is what we do is we collect a smaller set of higher quality images, and then we train a model on those again, starting from the pre-trained one. And control nets and fine-tuning only work with open weights models, which is why we try much fewer models than what we do for the default ones. Yeah, a quick illustration of what control nets do. So you can see here, this is from the paper itself. If we want to, for example, fix the composition of how the person is standing when we generate an image, we can provide something that is called a canny edge map. Essentially what you do is you outline, for example, the person, the shoe, or the building, or in our case, the Coca-Cola can, and then we'll always adhere to this composition when it generates an image. And so for fine-tuning, this is from the official guide by Stable Diffusion. What they tried to achieve was that so if you prompt Stable Diffusion 3 for just, let's say, a blonde girl, you get the image on the left. But in this example, they wanted to always generate in a specific art style. In this case, the more anime-looking art style. So what the author did was they collected about I think a few hundred images from the internet, and they manually labeled them in that specific art style, trained Stable Diffusion on it, the pre-trained version, and then afterwards what you get is the image on the right. So we conducted experiments with all the three methods we just mentioned. So for control nets, we found that we provided a canny edge map of Coca-Cola can, and indeed all the generated images afterwards, they were exactly in the shape of the Coca-Cola can that we wanted, and the logo was perfectly printed on it. However, the issue was that the prompt adherence got kind of poor from time to time. For example, you would prompt, let's say, a polar bear on the Coca-Cola can, and it would just put a polar bear behind the Coca-Cola can, but you would still have the perfect shape, just not what you want actually on it. For fine-tuning, what we did was we got a bunch of like real Coca-Cola cans from the internet from previous years with Christmas editions, and we manually labeled those. And we have about 10 to 20 of those, which is all that was available. This worked very well in the beginning. Like the shape and the style of it matched the previous years very well. However, we also found that sort of the model is only able to interpolate afterwards. So when you prompt for a polar bear on a Coca-Cola can, it would only produce a Coca-Cola can with the polar bear in the style of the previous years. So what we concluded from this was that basically if we want to still cover the design space as we initially set out to, we would essentially have to collect hundreds of or even thousands of images from the internet which don't exist, which we would have to make them ourselves, label them, and that kind of defeats the purpose of the methodology basically. So then we find that Recrad v3, which at the time of doing our research was the best model. With a lot of prompt engineering, it was able to perform surprisingly well, much better than previous two, at some cost, which we will show right after. But we decided to set out with this method. So the first thing is these models, they're trained on specific like writing formats. So if you deviate from that format, it doesn't usually do what you want it to do. So you need to prompt engineer essentially to get the best result. And this takes some skill and effort. And we don't expect our respondents in a real survey to actually go through this effort themselves. So what we did was we used GPT-4 to rewrite the respondents' prompts before the image was generated. And for this, we devised 4 instructions for GPT to rewrite the prompt. As you can see, we have prepare a can of soda, then prepare a can of Coca-Cola, and just fix grammatical mistakes. And then we have you are a creative designer, and then again a can of soda and a can of Coca-Cola. And we'll show why we do this in this example. So the prompt was a Christmas themed design with the northern lights and snowflakes, and then this was rewritten using the 4 methods I just described. So first of all, you can see that the Coca-Cola logo, it gets put on there fairly well, but not exactly as you would want in a real Coca-Cola can, but still well enough that respondents obviously recognize the Coca-Cola like emblems. So why we distinguish between soda and Coca-Cola was that, so these are 2, I think, average-ish examples of how Coca-Cola gets integrated on it. But in the lower sort of end of the distribution, it would get kind of messed up. So we tried to figure out if just generating a generic kind of soda and then photoshopping on it ourselves automatically would work better. And to test this out, we conducted a survey internally with just our colleagues, about I think 90 of them to 100. And so what we did was they filled in their prompts, we generated 4 images, and we asked them without them knowing which rewriting method was used, which was the preferred one. And we found that people strongly preferred when the elements of Coca-Cola were integrated naturally using the image generation method, and when GPT was a little bit more creative. So as an example, I think a lot of people simply enumerated what they wanted to see on the can. So they would just say, let's say, Santa and Christmas tree, and that's it. And then GPT, when it was more creative, would rewrite it to Santa standing under a beautifully lit Christmas tree, with ornamented with baubles and elves or something like that. And yeah, apparently that worked better for the image generation model. So essentially, we had GPT do a little bit more prompt engineering for us automatically. So yeah, so because the fourth method worked the best for us, we decided to use only this method in the real survey. So how the complete generation flow in our survey then looked like was, so the prompt first gets rewritten using method 4. Then we verify the prompt for unsafe elements. So we occasionally found that people would prompt for violence or political statements, for example. And since these images are shown to other respondents, we wanted to make sure that they're not included. Uh, then to reduce variance. So these image generation models, they're all random in the sense that the models they induce randomness. So every time, even for the same prompt, you get a slightly different image. And to make sure that uh, not too much of the quality was uh, caused by this variance, we generate 4 images, and we had the respondent select their favorite image. But just before that, we also again used a visual language model to again check if there were any unsafe elements or not, to make sure nothing managed to sneak through. Now, so now that was the survey part, and now after we collected the results, uh, we did the modeling, which I'll also quickly discuss. So we essentially did 4 models. The first one was a max diff using a factored covariance matrix. So we had about 50. Well, we had a bit more concepts, but there were some people who didn't put in any effort. So we removed those. So from the about, I think, 1,300, we made about 1,200 of those. And this is quite a large model for a respondent level max diff. So we used a factored covariance where we decompose the covariance matrix into factors, which made the model run much faster.
Yeah, and that's during the conference we had the lucky break that right before us, Kevin Lettery did a presentation on this. But if you're interested in how you can do this and how you can then get your model to converge in a reasonable time frame, then I think you can probably somehow get your hands on the conference proceedings and read what Kevin did.
Yeah, when the proceedings get published, just look for Kevin Lattery and Nino Hart. I think blending max diffs, historical max diffs.
Yeah.
And they'll explain it into more details. So additionally, what we really want to set out to was, we don't just want to generate images. We also want to understand what makes them good, because in the end, the AI generated images, they're good, but they're not quite production ready yet. So it really helps us to understand what makes them good and how can we improve on those. So what we did was we did feature engineering. So we went through all the 1,200 prompts that the respondents submitted, and we coded those features by hand. And we ended up with about 50 attributes across the 1,200. There were little bit more, but we tried to narrow it down to the ones that were most common. This was obviously a lot of work, and we had the fortunate that an analyst was able to help us out with this. But this is not, yeah, it's not very scalable. So we would prefer to do it with AI, of course. So we used a large language model again to do exactly the same, basically go through all the prompts, summarize them into about 40 to 50 attributes. But we still did it by hand because we weren't quite sure yet whether LLMs were capable of it yet. So we wanted to use the human coding as a benchmark. And then finally, so we went through the prompts, which was essentially the intent of the respondent. But the image models are not perfect yet, so they don't always incorporate all the elements that the respondent asks for. We try to address this by asking respondent, do you actually like this image? So the images all satisfy a minimum level of quality, but still there's a little bit of a difference. So to to check for this, we also code the attributes from the images. So instead of using an LM, we use a vision language model. And we again do the same, but now with the actual produced cans. Oh, yeah, and we use these all as attributes in a choice model, which we estimate again. So essentially, yeah, so that's summarized. We go through each prompt, we extract the attributes, then we remove duplicates. So for example, one respond might prompt for the Northern Lights and the other might say the Aurora, but that's essentially the same. And then when we've gone through all the prompts, we ask the LM to summarize it, to code it. And then we use the human coding as a benchmark. And finally, we all run it in the same choice model essentially, and compare them. And now Joris will walk you through the results.
Yes. So time for the results. And I have to admit, I was very happy when we got to the results because it actually turned out very well. So one of the things we were worried about was people not putting in enough effort, and that didn't happen. People created very different cans. We had very original prompts. We of course had a lot of people going for very classic Christmas elements, but we also had quite a lot of people really putting in their own spin with gingerbread houses, or some of the more like Christianity focused images were also generated. So there was actually a lot of differentiation also with animals, and so that was very nice to see. Here you see like a quick grab of features that we saw in the text, the image, and the AI codings. For a bit of an example of what then the cans looked like in the end. So on the left, we see some common examples. We have the Christmas tree as one of the big things there, but you also see the presents and the family that got found there. Then the snowman with the snowflakes and the candy cane, presents with cats. But then on the right-hand side, we have some of the more exotic examples. Less people put these in, but they did get in. And the designs did turn out quite well. So this, when we ran through the model and we said, well, can you predict how well something did in the max-diff depending on which attributes were shown? Ended up with these odd ratios. So we got actually quite different ratios. We saw that winter did very well. Polar bears and reindeer ended up very high as well. They did differ quite a bit between the different attribute codings. As we'll see later in the rest of the results, the attribute codings could have done quite a bit better, especially with fit to the max-diff. And then we, of course, also ran the covariance matrix max-diff. So from the covariance matrix max-diff, we got this. And when we saw this, we were like, yeah, this is working and it's really cool. Because we essentially found that doing the max-diff, these were the top 5 results and they're consistent. They're like, it's a consistent story of these are the things you really need to have. And these are things that still add value. And if you want to have your Coca-Cola can, take it from here. So this was really nice to see, and I was actually very glad with the methodology.
Also, something we forgot to mention during the conference is that we also contracted professional designers to generate a few Coca-Cola cans. And ours were scored higher, so that's also something very good to see.
Yeah.
You
Yeah,
guys
so we
should
had
reach out to Coca-Cola and see what they think.
yeah, probably we should, but then we'd be giving it away for free. So we kind of want them to come to us, and then we'll ask money for doing the research that we already did. I think that's the better way of
Yeah, maybe they'll see this recording and get back to you, hopefully.
yeah. One of the things that we do see here is that, well, probably you haven't seen it yet, but if you look at the first 2 cans, it's not actually Coca-Cola, it says Coca-Cola. And this is one of the things that went wrong from time to time with the labels, but it's just something you don't notice. So it's not something that interfered with the respondents at all. It's just, you just see the Coca-Cola logo, even though it's not really there. However, some people also had some of the worst rated cans. So we took a quick grab of the bottom of the pile. The very first one was someone that asked for a Coca-Cola can featuring 2 strippers smoking a joint and drinking Coke. So the image model is fairly well behaved, and especially because we had the safety features, this somehow slipped through as being just about okay. And then when the image was generated, well, to be honest, not much wrong with the image. It's a Coca-Cola can. It's not very Christmassy, so it didn't score very highly. The second one, I think, actually should have scored a little bit higher because it is quite Christmas themed. It works reasonably well. Admittedly, the logo didn't, a little bit something wrong with the logo on the top left side. But then again, probably the can would also have been rated quite a bit higher in a different country with a different cultural context, which was also, again, a positive note for us that you can also see some differences there. And then on the right, somebody did prompt Christmas colors, I believe, for this can because it wasn't flagged for invalid, but it just ended up being this and didn't really work out well.
To be fair, I went through 1,300 prompts by hand to see if they're invalid or not. So maybe one might have snuck through.
So then if we look at the model fits for a little bit more numbers and a little bit less looking at nice cans, the RLH for the max diff was by far the best. So the max diff came out with an RLH of 0.73, whereas all of the attributes model came out way lower. And this is including the anchoring. So we do see here that like even with the anchoring, the max diff is pretty good at predicting what is going to be good and what isn't. The hand coded is slightly worse than the AI text, which is slightly worse than the AI image, which is sort of what we expected. Because again, if you look at the final image, it doesn't always fit the prompt. So coding them on the final image probably works the best. There is still some things that we could probably do better here, which we'll discuss later as well. And then when we looked at the correlation, there was a higher correlation between the attributes coded models than there was for the max-diff models, for the max-diff model. So we see that the max-diff is sort of a little bit more different than the rest. They do follow a very similar pattern, and especially the worst rated cans were very easily distinguished by both the max-diff and all attribute models. So then into a little bit of current developments. We have a few future possibilities that we still want to do and a few things that we're already did. One of the things that we think would be really cool is if we could integrate this in a chatbot. So right now, people got 3 tries. They could ask for an image. We would show them the image, and they could ask for a new image if they wanted to, but they couldn't really edit the image iteratively. So if they asked for a new Coca-Cola can because they didn't like their first one, then they would have to generate an entirely new image that might not look like the first one at all. We also have, the model problem. Like I mentioned, we took Coca-Cola because we couldn't do every brand yet. That's been solved now. So that's very nice. One of the things that we're doing now is we can take any base image and generate it from that. There's some really cool examples later. Which also includes feature engineering. So for more complicated things like electronics, cars, you might want to say, well, I'm a car manufacturer and I want to see what consumers would want to do in the interior of my car, what they would think is the best. And then you could say, well, what I really want is like a cushion for the dashboard so that my knees don't hit the dashboard. Thinking of a crazy idea, like something like that you could prompt and then you could generate the car with that cushion in there. Then finally, we had the fit of the feature engineering. So that's something that we could still improve. It was a lot lower than the max diff, and there is a few things going wrong there. There's diminishing returns for additional features. So the way the feature engineering works is like the more positive features you add in, the better you expect the can to do. But that's just not how reality and how people view designs. Like this is not how that works. So there is some diminishing return of putting everything on a can and hoping that people still like it. There was also the combination of effects and features. Most likely, the people that really generated the manager, that generated more of the Christianity themed scene, would not have appreciated if we also combined in Santa there. They're just not things that work well together. Whereas both of these attributes will likely come out as positive. And finally, how correct the design is. The Coca-Cola doesn't really get noticed, but there are design flaws that AI sometimes does where, there's an arm missing that immediately really do bad things for your score.
Yeah, so one of the things we first thought about addressing was, so we have the features now. We saw which attributes would perform well, and now we can start with GPT 4.0, which was released
Well, more or less as we made the presentation.
Yeah, so basically past the deadline. We thought it released, and it completely blew out all the waters out of the water, all the models out of the water. So let's say these are the attributes that perform best, we can now iteratively add them. So for example, we can add a reindeer and it adheres to the original base. Also, by the way, we provide a base image, so we now add this Coca-Cola can as input. And we can keep adding attributes, and it is able to maintain not just the Coca-Cola aesthetics, but also the previous elements extremely well. So we just keep adding attributes that work well. Obviously, we wouldn't do this because there's diminishing returns. But now we can try different combinations of attributes that we think would work best. Obviously, any of them wouldn't just work best, but we can conduct another max diff, for example. So after a while, we would have a lot of different designs. We could change the subjects, the objects, the styling. Basically, we can now very easily and pretty much instantaneously create a whole bunch of designs based on the attributes that we previously extracted. And then the idea is, so we didn't implement this yet, but was one of the ideas, is that we could compare the respondent generated ones, and including the professional ones, and then conduct a final survey with the AI generated ones as well, to basically see where different attribute combinations place within the final ranking.
Yeah, because that's also an important part of the creation process is that you don't say, oh, one of the respondents generated a can that worked really well. No, after you found out what works well, the best can from the respondent, that's the moment where you work with a designer and you really polish the concept. It's not the thought that at the end of this research, you have the can that you're going to use. At the end of the research, you have the concept that you should have and the elements that you should have to create the can that you should use.
Yeah, I think for example something very nice would be as well. For example, we could include like different variations of a reindeer now, and then you can see it in the ranking again. How do they perform? And it could also give guidance to the professional designers in the end when they polish it. So the next thing is we already mentioned before, but we primarily chose Coca-Cola because, well, the high IR, but also because it worked comparatively well. Joris really likes magic, which is why we include this example. So with older models, so this is also all from Recraft. The older models, it didn't work as well. So on the left, you see a real package, a pack of magic cards. For reference, Magic is a trading card game.
Fantasy trading card game. It's really cool. You have, okay, sorry. Yeah.
So on the left, we have a real one that we just got from Google. In the middle, if you just prompt for, can you generate a booster pack of Magic the Gathering cards, you get something in the middle. And it does recognize Magic, but it already messes up pretty badly. But when you ask for put a Santa themed Magic booster pack, it completely disregards the Magic elements. But now with image editing models like GPT-4o we mentioned, but also Flux Context, which I think was released about last week or maybe 2 weeks ago, we are no longer restricted to this. So what we can do is we can just add a base image, for example, what we show on the left, and then we add the prompt. For example, yours wanted a SKIM themed Magic booster pack, which you can see here, and below you see on the left the original image, and we prompted for a Christmas outfit, and it added on very well. So this basically expands massively what we are able to do, and I think it will only get better. I think ever since since OpenAI released their model, there's been another arms race towards image editing again.
Yeah, and I think that's also like one of the cool things is, Peter already said like 2 weeks ago, Flux Context came out, and that's very recent, and suddenly we can do cooler things. So the top image between the two magic packs was generated by me with 4.0 because I wanted to see if I could get the skim style, the skim feel, and like really, our company, right colors. You can see them in the background as well, and if those would go well on the magic pack and it would all work. And that did, but it did take a minute or so. Like the generation took a minute, which of course within a survey, if you want them to generate 3 images, you need people to wait a minute. It's just not really going to work. But then Flux Context comes out, and that's the bottom one, right?
Yeah, that takes about 10 seconds, 10 to 15 seconds.
It takes 10 to 15 seconds, and you can either have like a little timeout, or you can put one question in between, and suddenly you can on the fly get the images for the respondent again.
And so we initially had this in mind for like with Coca-Cola's more creative design. But as Joris already mentioned, this also works for like more functional design now. So for example, previous models with you couldn't say edit this Whirlpool refrigerator. But now, so on the left, you see just the original image from Whirlpool. Uh, Also, we're not associated with Whirlpool, by the way. But in the middle, we asked, could you remove the, well, I think it's ice dispenser. I think ice and water dispenser. And it does so very well. And on the right, I said, make the door handles smaller and make them pink. Uh, so this, again, expands what we're able to do with AI. And now we have a demo, which hopefully still works after
This is the
we
this,
exit PowerPoint.
this is the exciting part where we hope the demo works.
And the screen share still works as intended.
That's
Hey,
the
lots of
second.
respect for pulling off a live demo, you know,
If it works.
if it
Can you
works.
see the screen with the web
Yep.
browser?
Yep.
Great. Then I've got good chances that it's going to work. So the example is again Magic the Gathering because that's great. So if we get to the prompt part, here again is the pack as mentioned for the flux context that we did. And then essentially we can put in a prompt here and we need to think of something. So, oh, I can type, can you replace the character with Santa and add some elves next to him. So normally if we did a survey, then we would add some little prompt engineering to it in order to make sure that it keeps the pack and everything goes all right. But since this is a demo, it's not in there yet, and I'm going to add it manually so that it sort of keeps the right concept. Please keep the concept, a booster pack, the magic logo, and the other text elements.
Hopefully it works.
Hopefully it works. If it doesn't work, then I still have a tab open where it did work. So now there's a please hold for 10 seconds, but this is also where we normally have a question. We just ask like some demographic questions from the respondents and we say like, well, we wait for your image. And then, yeah, it generates the magic packs.
And then Santa with kids. Elves.
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 So
I'm
that's
just gonna jump in. That's so cool that it can generate those images in the middle of the survey. Impressive.
yeah. Yeah, so yeah. That's sort of for the respondent experience.
Well, we have a bit more. So we ask people to select their favorite ones. Uh, we go through some questions,
KPI ranking.
and now we get to see other designs we made. For example, the character fighting a zebra. Then this is just a massive exercise.
I remember during the conference, I think it was Brian who asked us, "Are you actually getting paid to have this much fun?" So we do that. This is actually, I highly recommend doing this kind of stuff because it's a lot of fun to do.
Yeah, that's cool.
Yeah,
Oh yeah, there you can see our Santa
yeah.
compared
So
to
then it also pumps in the Santa with the elves.
French. That is
Fr
French magic.
French with the baguette, yeah. And then here's the little example of the anchored part of the max diff, where you say like, I would or I wouldn't buy this booster. Clearly, we'd buy ours.
So this part you weren't able to do at the conference. This is new and improved, and you have more time. Is that right?
So yeah, so especially getting the magic pack to generate correctly, like getting any brand with just a base image and getting it to keep the important elements. So it keeps the cards, it keeps the age, it keeps the set booster at the bottom. Like those things are important to generate a good magic pack. Otherwise, it wouldn't really look like it. And previous models would not do that consistently at all. And right now we can actually sort of get that every time. So that's definitely an improvement that we've had since the conference.
Yeah, you're just varying parts of the image, not everything. You're keeping other things consistent. Yep.
Yeah. Yeah.
Yeah, that's it. Oh wait, yeah, we have back to the PowerPoint.
We have there we go. One more beautiful image generated.
Yeah, questions? Oh wait, no, I think that we. Oh wait. The screen goes back to you, Justin. Now.
Yeah, very nice. Appreciate this. This is great. Let me steal the screen from you real quick, and then we'll get to Q&A. Again, Q&A coming up, but just a reminder about next month's webinar, Relevant Items Max Diff from Chris Chapman. Also, July 21st through 22nd, come out here to Utah for some Sawtooth research training, and then our preference modeling event in Germany in September. Yeah, check us out. I believe the survey that you just showed was you did that in Lighthouse Studio.
Yep.
Yeah, so Lighthouse Studio, very flexible, allow you to do these kinds of things, which is really great. We also have a product called Discover that we'd like you to check out if you haven't. With that, we do have just a reminder, we're going to send everybody that registered for this webinar a recording, and also they've graciously agreed to allow their slides to be shared and their email addresses here if you want to ask them some questions. Okay, so you can see at the bottom we have a few questions here. Would you guys like to read the questions and answer them if that's okay? And we got two.
Yeah,
Yeah,
sure.
sure. So, how long was this process from conception until now? So that was actually last August until now, and yeah, we're still improving. So it's actually the idea is less than a year old.
We didn't work on this like full time near time. Right, sorry, sorry.
Yeah,
I think we like because the call for papers is around September or something.
yeah,
So I think we sort of yeah wrote down the general ideas, and I mean our final project was still a bit different from the abstract that we submitted. I think maybe from October or November I started working on more full time on it because the image generation was more important in the beginning, and then around January, February
yeah.
you started to take so maybe full time equivalent, maybe 3-4 months for the project for the initial project, and then we're still developing it right now to incorporate like all the newer models basically.
Oh. Then we have what's the least SKIM would charge for a project with a similar scope to the one presented? So that's a difficult question, especially because there's quite a bit of figuring out the right prompt, getting the prompt engineering, and it really depends on what exactly you want out of it. So we do a lot of custom work. We don't do a lot of templated projects. That is, we don't have some sort of price list and you just select, oh, I want this type of project for this price. We always have a conversation, talk about what are the options, what would you like to do, and then we go through that. So hi Lee, great presentation. Is the source code code open source on GitHub?
It is not, and I don't think we're allowed to make it open source.
Uh,
We can't make money if we make it open source.
I think that's going to be the conclusion. We can try and ask the people from the innovation team here if they would allow that, but I think Peter has the right answer here. That's yeah. Sorry.
Can this AI survey tool for the questions be used offline? Uh, Theoretically, yes. However, so OpenAI's models you can't run offline because like they're proprietary models. You have to go through their APIs. Same for Recraft, but for example, Flux is open weights. So theoretically, you could run it offline, which we haven't set up yet, because these models are absolutely massive, and they require an entire GPU cluster just to set up. Which, for reference, one GPU costs like $30,000, and you need dozens of them. So you can rent them from AWS, for example, but that managing such a large infrastructure is not exactly cost efficient unless you're Meta, Google,
Yeah, so
etc.
I think the answer comes down to theoretically it's possible. In practice, it would always be cheaper to just get an internet connection somehow than it would be to do this locally.
Did you have you know, any performance issues relying on the outside, AI image generation? Were there times where it like timed out or didn't work correctly, or was it pretty nice and consistent?
I
It
think about
definitely problems.
we definitely have problems, but I think it's like 95% of the times it works. So
Wow.
5% is just I think we just kind of accepted the loss.
Yeah, and there's also quite a bit of getting the prompt right. Like that prompt engineering part where we do the rewrite, that actually makes a big difference. So in the beginning, when we didn't have that, the Coca-Cola can would often be like the characters would be behind it, or an entire background would be generated. Like a lot of weird things would happen. But as we got the prompt better, we also got better images and more consistent images. I think when we tested the survey, like you had saw the four images, and if they didn't load, it would actually show a little text with the image isn't loaded yet. Please refresh the page in 10 seconds to get your image. I think 1 in 3 images would load too slowly every 10 times testing or something. So almost never.
Another question before we get to Will. Can you share a little bit about the cost of using the AI, how much it costs you, or I don't know how much you're willing to share, or what does that look like if attendees were wanting to get into this? What's the cost of using the AI?
This is publicly available because we just went through like we went through a hosting company that has the GPUs. It was $4 cents per image.
Yeah, so $4 per image. Then you have 1,300 respondents that can generate up to up to 12 images. So that wasn't the big cost in the project.
Cool.
Like yeah,
Okay.
so we had like $200-300 in the end of.
Yeah, something like that.
So really expensive. Yeah, if you want to get back to the question.
It's less expensive if your company foots the bill. Um, Will Scott, this was fantastic. Do you think anything is emerging as an AI capability that will take this approach to a new level beyond performance, which Justin mentioned?
I think the thing with these AI companies like OpenAI is that they don't want to invest in something that doesn't make money yet. Uh, but so I think originally image generation was going a bit slow, uh, but because there wasn't really a market for it, like it's nice you can generate an image. But I think OpenAI really tried to market their new model 4.0 with image editing capability as a replacement for Photoshop. And since then, you've seen a lot of companies, for example, Google's new Imagen also has editing capabilities, Flux context. Imagen sucks though, so that's why they didn't include it yet. But I think companies are really trying it out more now, and with how much money there's being thrown into it. I personally, from my opinion, I think like image models they generally lag behind language models a bit more. For example, there's news like GPT 4.5 is smarter than a PhD candidate, whatever. While image models sometimes can't even generate a Coca-Cola can. So I think there's still a lot of like space for them to improve. And now that like these big tech companies see that there's more profit to be gained, I think we'll see a lot more advancements in the near future.
Yeah, and then there are a few things that would really help the approach. Like the first thing already happened where we can start doing the changing features on a car or on a fridge or anything, and you can just think of, oh, actually, I think this would be a great addition to my already existing product, and you can generate that image. It's working. It could still be a lot better. So I think that's also one of the things where if that gets even better than it is now, it'll be easier and more consistent to use in a research setting.
Also, something very nice still. First, OpenAI was the first one to make image editing really good. But despite their name, they don't publish anything. But Black Forest, the company behind Flux, they actually do publish everything they do in quite some details as well. So if you're actually interested, it's a very technical paper, but you can look up Flux context and they have a paper on it. They don't share like their training data or something, but the mathematics behind it, they share everything. So I think this will also help a lot with other companies learning from what they did, and the growth will just be exponential from there onwards, I think, as if they keep publishing.
Then we have a follow-up question, please. So what will be your recommendations for a survey in low research setting if one
No
wants resource setting if one wants to apply that?
What do you exactly mean with low resource? As in
Well,
low money?
so if you don't have internet, then it becomes pretty difficult pretty quickly. Although there are simpler models that you can run locally. So all of the models that we use, they're all, like Peter mentioned, in order to run it, you need a lot of GPUs and it's very expensive.
Although to be honest, I think the Flux is, for how good it is surprisingly like good. They haven't open sourced it yet, but they said on their technical report soon. Uh,
So yeah, you can go for one of the more easier to run models. You could try to get that to run locally, and then you could do it with a little bit less. You could do it without internet essentially. For a lower resource setting, if you want to spend less money, there's also just cheaper models.
but
Like
I think to be honest, it's quite difficult. For example, I ran Stable Diffusion 3, which is still on paper much smaller model than Flux Context on my personal PC, which for reference is still like a 2000 euro PC, and it takes about a minute to generate an image. Uh, but that's one GPU, right? And if you have hundreds of responses at the same time, you need hundreds of GPUs.
yeah,
So
but
that the
in
cost,
a lower research setting, say if you were doing research somewhere where you don't have internet and you're walking around with your own iPad, then you could run it, well, maybe not on an iPad, but you could run it on a laptop
if
that you
you
could take
want,
with
if
you.
you just want to generate images for yourself, you could do it on your
Yeah.
own PC. Or you can rent a on like Google Colab, for example, it's very easy to rent GPUs, and that's quite easy to set up. If you don't need to make it scalable, sort of, for a lot of respondents, basically.
Then the next one, have you looked into the ethics IP conversation around this with, for example, with Disney and Universal looking to sue Midjourney? Maybe not an issue if a client gives you permission to use existing assets. Yeah, I think that's the big thing. If we're doing a client project, then implicitly the client is giving us permission to use their assets to show to respondents. So then we wouldn't really have that problem. Maybe if the image model generates something that has some IP issues, that would be annoying. But then again, I think probably it wouldn't really be our annoying. It would be
Right.
the image
I-
models.
I'm not a lawyer, but like the company we work with doesn't have to use the generate AI generated images, right? So like if they see copyright infringement,
Yeah,
they're
yeah,
not going to include
true.
it. Like it will show up in a respondent survey, I guess, but it will not be used for commercial purposes.
Yeah.
So my non-professional legal advice is should be fine.
Go for it.
Yeah. Yeah, so while we did this, we are lucky enough to have a legal department that we can ask all of the questions like, will this be okay? And can we do Coca-Cola? And then they'll come back with, yes, you can, but you need to do this. And then they explain, yeah. So that helped us a lot through this as well. Then we have not a question, but a compliment for the creativity and the example of AI application in market research. So thank you. And one more on the cost-efficient alternative and the papers. So the paper
I guess the
was,
flux context paper, I think. Yeah, I can link it. I don't know if, how we can I can
uh,
exchange with Justin. You can send an email maybe. I don't know how it's gonna
Yeah,
work.
send me if you whatever you want to share in the email that I send out, send it to me and I'll include it in the email.
yeah.
Okay.
And there was also Kevin's paper for the
Well,
covariance matrix, which was
unreleased paper.
unreleased paper. Oh yeah, true. That's an unreleased paper. So
Right.
that's coming in the conference proceedings.
That's right. I
And
think I have a final question. The survey seems kind of enjoyable for a respondent. Did you get any feedback on like them more interested and engaged because it was kind of fun to create their own thing?
yeah, so we did a few questions based on did you enjoy the survey, and we also let them do the KPIs for their own and for other people their designs, and the results for that was they enjoyed the survey a lot. Like people really liked this concept, which I can imagine. I think at the time we did it, probably it was the first time they saw a survey like that. So there is a little bit of a pitfall there as well, that maybe the results we got were a little bit better as we got better respondent engagement for the novelty of it.
Yeah,
And regarding the KPIs, we saw that people rated their own image a lot better than they did others. So that's also why we didn't include it in the max diff. You didn't never
interesting.
saw your own image in the max diff because you'd be biased heavily.
Interesting. Peter and Joris, thank you so much. Great presentation, very interesting, and we love it. Thank you so much, and we'll see everybody later. Have a great day.
Thank you for having us.
Thank you.